Alright guys, so this video series is by Practical Example, and I had a video series that I did on Python back in 2016 that was quite popular, but I started the series off with like giving some practical examples, and I think that was really the popular part of that series. But then I kind of went astray with just kind of focusing on syntax and showing all the different built-in types in Python, and I was showing like things that like weren't really practically used all that often, and like it just like kind of just doesn't really captivate the audience anymore. So that like I'm trying to like at least lead by some sort of programming example problem or whatever that we're trying to solve when we discuss the different types and things that you're going to do inside the Python language. So the first thing we want to do is focus on the string. This is actually a string value right here. So if we were to put this inside a variable, and we'll call this my variable. In Python, you're going to see commonly that local variables typically they're all underscore with this, they're separated by the underscore, they're all lowercase. A lot of Python code is written in that way. The linting is going to give you hints as well as far as how to write properly. So if you want to go ahead and disable and put it back to its original setting, you can do that. But by convention, we're going to just name our variables in this way, all lowercase, all words separated with an underscore. And we could say this is a string. So a string in Python, it's going to look at this variable, it's going to assign a memory slot for it, and then it's going to assign memory to hold data that it contains. It's also going to listen for any changes that are made to that variable so that it can end up stamping out a new object with that new value. And if we wanted to actually use the variable instead of this hard-coded string right in there, we could do that, and we could say my variable, and we're going to print that to the screen. So if we go ahead and run this, we're going to see in the debug console this is a string. So it works the exact same way, but Python has a built-in, I can go ahead and see the type of, or just type of is JavaScript. So I could say type, and then inside a parenthesis after the type, because this is actually a built-in function within Python, you can see that it's class type, takes in an object or name, and that's what we're passing in right here. So it's that's the first argument. It's the only one that we're worried about. Those other two arguments are optional, but you could read more about passing in those arguments and seeing what your results are and things like that if you wanted to. But for right now, I just want what it is, what type of variable is my variable. Is it a string or is it something else in Python? So if I run this in the debug console, you can see that it is a class string. So that tells you there's this built-in class within Python that is a string, and you're like, what is it? And if you were really nerdy and wanted to read up on this, you could actually go pick your version of Python 3.6, and you can see that there is all this documentation on the official python.org website. This is all the nitty-gritty details. So if you really want to be like a thick glasses nerd Python developer, like reading through all the semantics of all this stuff, like you're going to learn a ton about the language and what you can do. You're not going to use half of it probably, but it's all there for you. So if you ever wanted to like deal with, okay, there's some sort of built-in class within Python called string, and that's the case. So you would never want to create your own class called str. Because Python has these built-in classes already. So those are like the most important concepts around some of these features, and like even the lesser known features that you might not deal with, like range operators and things like that, which you do kind of deal with those a lot. But just as an example, say you didn't, then you would still want to be aware of those edge cases, so that you're not like overwriting some of the core language of the Python runtime or whatever. So anyway, linting also will help you with that as well, maybe even the compiler. So let's go ahead and look at a few other types real quick, because I want to show you how to practically use the string type. But let's go ahead and create just some other type. We're going to say other type. What is this? I'm going to assign a number to it. So in Python, that's all you have to do. You don't have any semicolons or anything like that, like if you've ever seen JavaScript or other languages. None of that stuff matters within Python. And now let's go ahead and we're going to look at the type of other type. One of the things that Visual Studio Code gives you, which is really cool, is it gives you this code hinting. So like anytime it pops up like that, you can use just the tab key, and it's gonna pre-fill what it is that it thinks you want to type, and that's like 9 times out of 10, that's usually what you want to type. So having a text editor like this is really cool. Now in the debug console, you can see that's a class of int. So we have this integer type. Let's see, another type equals, like, what if I said 1.4? What is this? You can double click and to select the whole thing, tab again, press play, and you can see that we have this now floating type. All right, so there's all these different types within Python. We're not going to discuss all of them, but the fact that the thing I really want to explain is that, like, we have, we'll just say 1 int equals 1, 2 int equals 2. And I'm going to get rid of these real quick. And what if I wanted to say 1 int plus 2 int, and then just print that out, press play. You can see that we're still getting a type of int. So we can actually add 2 variables together and we can still get their type of. Let's go ahead and get their value by removing that type statement in the parentheses, and make sure you do that. Another thing too is that if you highlight over the start debugging option, I thought it was going to give you a hint, but you could press F5 if you wanted to, and it's going to start the debugger automatically. So you get the value of 3. Now what happens if you try to do something that's not mathematically possible, and that's try to take, let's just say this is not possible. So we're trying to take a string and we're going to add it to an int. So we have 2 different types within Python, and we go ahead and press play. You can see that we get this error, and it says unsupported operator. You cannot add an int and a string that's not mathematically possible. It doesn't make sense. This isn't a mathematical value. It doesn't represent anything, and you're trying to combine the two as if they do. So Python's going to freak out on you whenever you try to deal with 2 different types like that. The interesting thing about JavaScript is we could do the same thing. 1 int equals 1, and then 2 int equals this is not possible. And then we could say just go ahead and add 1 int plus 2 int. And you could see it adds 2 different types. It doesn't complain. That's because JavaScript is a weakly type language. Python is a strongly typed language. A lot of people think Python is like some sort of weakly type language like Perl or PHP or JavaScript, but it's not. It is strongly typed. It enforces those types and makes sure that if you want to do that, you have to explicitly try to do that. So like in this case, I'm going to say, you know what, 2int, I'm going to force you to be an int. So I could say int, and this is called typecasting. What we're doing is we're taking the type of string and we're casting it to a different type of int. And we're going to try to force Python to behave in that way. But now you're going to see that we're going to get this invalid literal for int with base 10. Basically, Python in its built-in int type is expecting actual numbers that the computer understands. It's getting string values that it doesn't understand as numbers. So this is simply not going to work ever. Python is going to prevent that type of bullshit from ever occurring. Whereas, you know, these weakly type languages like Python, or not Python, but PHP, JavaScript, and Perl and things like that, they will just let you do it. They won't complain about it. That is one of the main reasons why companies do not use a language like that. Most of the time, you're never going to want to do some crazy stuff like that. But in this case, you're forcing Python to try to do it, and it still doesn't understand it. So, like those other languages shouldn't understand it either, but it just tries to figure it out, and it auto-magically figures it out for you. And if you've ever heard of the term magic with a framework and things like that, that's what they're talking about, like, you know, magic that goes on behind the scenes. Ultimately, there's some sort of decision by a developer who was developing JavaScript or Perl or whatever to say, you know what, we have these type collisions, don't even care, force one or another into it. You know what I mean? Like, so they know that, like, in JavaScript, you can't obviously force a string into an actual number, so it's going to go the opposite way, and it's going to force a number into a string. So, but it's just weird behavior. So anyway, let's go ahead and talk about a practical thing that we can do with a Python string. We're going to actually write a simple HTML page, and we're going to say the thing's going to have everything that an HTML page needs. There's going to be a title in here. test page, and we're going to close off the title. So just try to follow along with what I'm typing here. It's all just regular HTML. So hopefully it's familiar to you, and then we'll just say hello world. Let's close off our body tag and close off our HTML tag. And now we can go ahead and close that off. And we're going to go ahead and instead of printing to the screen, I mean, we're not going to do that. We're actually going to create an out file. So we're going to say my out file equals, and we're going to say open, look for a file that is called test and the current directory, and if it doesn't exist, go ahead and open it. We're going to make sure that the test is dot, and we're going to call this index actually. We're going to call it index.html, so it's an index.html file extension. This dot says go back to our root directory, or the current directory that this file is sitting in, / and it's going to create this index file. This W says write to it and open it, like create it if it does not exist. Now sometimes you're still going to get these error messages where like the linter is stuck, so you're going to want to just press Control S so that the linter will go away from its error messaging. So what you can see is if we go ahead and we try to run this program and we go to our directory, you can see that I created the index.html file, but there's nothing in there. But that's pretty cool that Python actually created an actual HTML file. If I go to where my directory is located, I can go ahead and double click on that file, and you can see that it's actually opening up this page into a web browser, so that's pretty cool. So now I want to show you that we can go ahead and alter this program to say, you know what, after you go ahead and create the file, I want you to go ahead and write to it. And if I go ahead and say dot after my variable name, you can see that we have all these different options that we can read a file, but what I'm going to do is say write. I want to actually write, and I'm going to write my variable value into it. So we're going to write our string value, which is actually an HTML page with this content. So we should get a page title in there. And also a hello world tag and everything like that. So if we go ahead and we run this, then we can do that, go back to our files, double click the page. You can now see that our index actually has the values, so that's pretty cool. We can also reveal in the Explorer and then double click on it, and you can see that we have an actual HTML web page, which is pretty cool. Python generated it for you just like that. So you could have had whatever sort of value inside of here as your HTML. Maybe it's a file that you open up and you like inject all that, but this is all you really need. So you could have this index file sitting on an Apache server somewhere, and you could deliver it to the entire internet, you know, and it's just as simple as that. So even without databases and things like that, like you could literally set up something so basic where it's like, I have an Apache web server and I run a Python script that writes a bunch of HTML files based on like data that I scrape across the web or whatever. And then I write these HTML files, not even to a database, but to a straight file system on the Apache web server. And it could just literally like serve static HTML, displaying the data that you've assembled and things like that. And nowadays with like client side, these serverless servers that they're talking about, that's all they really are. And they make a lot of sense because you could pass down a lot of code, including JavaScript and all kinds of stuff, down to the client that is just like rendering most of the UI, if not the entire UI. And all that thing's doing is just making like maybe AJAX calls out to some sort of RESTful endpoint. That could be like a Python Flask server or something like that. And it's just passing data back and forth. Like literally you could start an entire operation with just Python code.